next, I'm really looking forward to hearing what Mike Marble here has to say. He spoke for his first time, last time here on this stage, and on his Windows as a Service model. So we're looking forward to hearing what he has for us on Power BI and OSD stats. And so he did a great job, and so it just goes to show you that you don't have to be a consultant, a conference speaker. You can be a regular person like Mike or I that can step up and do a great job and kind of share what you've been working on and help the community. So that's what it's all about. So without further ado, Mike.
Oh yeah, no pressure or nothing. Yeah. Okay. Like I said, I want to come in to talk about essentially displaying and reporting your OS deployment statistics using Power BI. Give a little background. My name is Mike Marable. I've been with Michigan Medicine, previously known as the University of Michigan Health System, for about just north of 13 years, where I've been their OS deployment architect. Before that, I used to do OS deployments back at the corporate headquarters for Borders Bookstore. If anybody remembers them. And where did it just, there we go. I got my email up there. If after the fact you come up with any questions, you think of anything, feel free, email me. I'll try to do my best to answer them that I can. Twitter, I got my blog. GitHub down here. Everything I have for this presentation, the PowerPoint, the sample files, the Power BI report, the PowerShell script, everything like that, I got it up on the GitHub repository. So, go ahead, go out there, you can download it. Afterwards, I'll get the PowerPoint up there for it, but otherwise everything else is up there. Excuse me. Real briefly, going to break this thing down in about three quick little sections. First off, why would you want to do it? Why do you want to go through the trouble of collecting your OS deployment stats and displaying them? Okay, if you decide you want to do it, how are you going to collect that information? And finally, how are you going to display it? First off, why? Who here is responsible for their OS deployment task sequences? Pretty good sized population. Is this, hopefully this is actually a familiar scenario. You're cruising along in your day and you're just fine, and then out of the corner of your vision, your boss wants to talk to you. Because your boss heard through the grapevine from somebody who heard from somebody who heard from somebody, the build's failing all the time. Build fails all the time, and the 1 in a million times it actually is successful, it took all day. Your boss wants to know what's going on. It then brings up an awkward conversation. Sorry, I'm a little nervous up here. Where you're immediately then defending what the work you've been doing. I didn't like that, so I created this. This is the end result of probably about 2.5 years of collecting data on our Windows 10 deployments. I can go through, I can tell exactly how successful it is. I can tell you, it's not failing all the time. We got like a 92% success rate. It doesn't take hours. Our average build is 85 minutes. I can tell you we're a nomad site. So I can tell you how many machines are being built at our fast locations and how many machines are being built in our remote sites that require running nomad. I can tell you why it's failing. I can then break down exactly telling you, what percentage of every build is failing for what reason.
What is that? That was cool.
What
you just won the day.
Yes. Good thing. All right, a side note. When I was here last time, I was here last time. I brought my laptop. I was up here. I was about ready to, I was hyperventilating. I'm like, oh my gosh, I'm going to present. And they're like, your laptop won't connect to the AV equipment here. So they were like, okay. So they, I think it was Jeff got a laptop and hooked it all up and got my PowerPoint on there. And he handed me this little stick like this and said, just push this button and, it'll advance it to a little presenter. So afterwards, I got to talking to him. He was telling about all the features for it. And I'm like, that's pretty damn cool. So when I picked one up myself, yeah. Can I zoom?
Do other things. And the whole user group went
Yeah, there's like a couple other. Oh well, there's a couple other ones in there. But all right, side note done.
updates.
Yeah.
Have my attention.
Back on track. Yes. So, how did I go about doing this? Well, back when I first started this whole thing, this was about 2.5 years ago or so. My ambitions were much smaller. I mean, all I was concerned about was the success rate and the average build time, because that was their complaint. It takes too long and it fails all the time. So I worked out, and at the end of every my build sequence, I was collecting whether it was successful or failure, and I would calculate out the elapsed build time, write that to a CSV file, and I was just pulling it into Excel. And over time I started expanding it, pick up a few more other task sequence variables. And I would, with pivot charts and pivot tables and things like that, I was creating my reports. Someone tipped me off, well, why don't you try Tableau? So I switched from using Excel to using Tableau, but I still kept using that same CSV file. And then I found Power BI, and I just continued moving along. So this is what I've been creating here with CSV files, essentially. This one I created for this presentation. I have a sample file, again, that's up on the GitHub, as well as the Power BI template for this, or up there on that. The sample file is a CSV that's got about, I think it's just south of 500 build records in it that I use to create this exact presentation, or this Power BI report. So that's the why. Question is, okay, sounds great. What do you got to do? First thing you need to do is figure out what's important to you. Usually a good starting point is if your task sequence has various forks in it, that'll take it down a whole separate path, and you're keying off the task sequence variables. We're all using that. That's a good starting point as far as what should be collected. For example, like I said, we're a 1E customer. So within our custom settings INI file, based upon the based upon the default gateway, we'll just send a variable to it. You're in a slow site. We got a variable nomad slow site. Set it to true. If you're on the backbone, set it to false. That's what gets in my CSV. I recorded that. That's where the data for that one comes. We have an HTA front end where the build text can decide and select whether they want to use USMT to back up and or restore the data. Those get assigned to variables. That's why I get those two little gray ones over there. There we go. See? Might as well get my money out of it. So, like I said, you want to find out what's important to you. So at the end of, like I said, I figured that out. Like I said, it's been growing over time. I started collecting model information, failure reasons, things like that. And then I have a PowerShell script that is executed at the end of my builds that just writes the stuff to a CSV file. So I just have a CSV that just grows and every build gets logged to it. And like I said, it collected it through with PowerShell. In your task sequences, for this to work, you want to avoid this. I mean, beside the fact you want to avoid a failure, you want to avoid because you're going to get a failure, no matter what. Some point in time, you're going to have a failure in your build. You don't want to just throw up the splash screen with its hexadecimal error code, which means nothing to anybody. So you want to actually catch and control that within your task sequence. That's essentially done. There's several ways you can do it, but they're all variations of the try-catch process. You're going to have the try section. That's where all of your heavy lifting for your OS deployment is going to happen. Everything that you currently have in your task sequence will be executed in there. And then in the catch blocks, based upon whether you had a failure in your sequence or your sequence was completely successful, you'll fall into one of those two groups, and you could do anything. If it fails, you could page the on-call. You could zip up all the log files and move them to a server. Excuse me. Again, second time presenting. Very nervous. Deep breath. So, and then you find the finally section here. Regardless of win, lose, or draw, that process, that section will be executed. So in my case, and this task sequence is also available on the GitHub for anybody that wants to tear it apart. The way it works, essentially, is in that main group, your task sequence runs along, and SCCM after every action will assign whether if it was, my mind is racing. If the action succeeds or fails, it will assign a true or false to the variable SMSTS last action succeeded. Okay? So if the action succeeded, that'll be set to true. If the action failed, it'll be set to false. If it's false, then the task sequence engine will check to see if that action was set to continue on error. If it isn't, it goes to the parent group, checks to see if that was set to continue on error, then it works its way back up to the top. If it comes up with nothing, then you get the big pop-up about, the hexadecimal failure code. So in this case, at the very top, up there at the main group at the very, very, very top, you'll have that set to continue on error. So then, if you have a failure, it works its way up to that, sees it's supposed to continue on error, drops down to the next step at that level, which would be the failure group. That group is set to run if SMSTS last action succeeded is set to false. You had a failure, runs a step in that failure group. If not, drops into the success group, processes the steps there, drops into the cleanup and logging group in my case, where I do my actual logging and the execution of the PowerShell script.
So, Mike, I got to ask real quick. Have you blogged about that? I use this a lot, but you're presenting it really well. I've got a feeling. I know a lot of people just love the continue on error, right? They just like, yeah, whatever, it does what it does, and people complain. Like you're saying, it fails all the time.
Right.
I mean, there's got to be some people here like, oh my God, I get it now, right? I'm sure there's someone. Yeah, there's probably some people that don't do this because they don't get this. I'm not listening to you, but I have not. You present really well. That's awesome.
Thank you. Like I said, there's different ways to do it, but I mean, they're all essentially going to be variations on the same theme. All right. I'm not going to go through the whole task sequence. Just going to want to catch a couple of key points in it that are related to here. Up at the very top of the main group here, I set these 3 task sequence variables. Now the first 2, OSD version. Now these are for my own personal use with this script for housekeeping. Over time, when I first started this, I was just dumping everything into a single CSV file. Like I said, I started out very simple before I came into this point. I decided I needed some sort of version control, so I could keep the results from task sequence version 1 separate from version 2, separate from version 3, and so on and so forth. So I set this variable at the very top of my task sequence, and all it is the version of the task sequence. In this case, the one that's up here is 3.0. The script will incorporate that into the file, the CSV file name. So I could tell this is the CSV for version 1.0, this is for version 2, and so on. The OSD branch. This I have set for demo because this is a demo, but in my environment at work, I will set this to dev. I'm doing development work on a new revision of my task sequence. When that's complete and it's ready to go to QA testing, I'll set that to QA, and when it's done with QA, it goes to file, it sets to file, it sets to production, and it goes to production. Why? In the PowerShell script that collects all the data, this will correspond to a folder. And the screenshot really doesn't illustrate that well, but it will, the PowerShell script will take that and create a separate folder so that the testing results from dev are separate from the testing results from production. Learn that the hard way. First time I was doing it, like I said, everything was just going to one CSV file. It was great, it was wonderful. Start development work on the second version of my task sequence, and of course, in development, things fail, things fail, things fail. You try it, you fix it, And then, whoa, all my stats just went in the hole. That's because all my development stuff right there alongside production. So, like I said, the script then, so you can see where it appends the version to the file name. And like I said, it just equates to a separate folder. The third one, recording the build start time. PowerShell one-liner creates this variable OSD start info. That's clicking start on the stopwatch. Clock's ticking. Of course, like I said, the rest is just straight up, the typical OS deployment task sequence. Getting into the catches. So I got two groups, for catching failures and one for catching the successes. If, like I said, any step fails in the task sequence, it'll set that variable, last action succeeded to false. There's logic on that failure group that if that last action succeeded variable is false, it'll execute it. And in this case, I use the set dynamic variables to collect some information. Now, if you're using Config Manager 1810, this SMSTS last action name will give you the last action that was run. And if that's the case of a failure, that's the failed step. If you're using 1806 and prior, you have to essentially mine the SMSTS log to pull that information. And I got a prior version of the script that did that. I'll get that up on the GitHub as well. So I assign that to a variable, failed step name, which the PowerShell script will then plug into the CSV file, the failure. The all steps succeeded equals setting that to false. I'll get back to that in a second. That ties into keeping it from stumbling into the success group. I'll get to that in a moment. Then I set a variable OSD results to failure. This will be passed as a parameter to the PowerShell script to tell it, okay, there was a failure, so in addition to logging as a failure, that you also have to pull the failed step name recorded. In the success group, that same variable would just be set to success. Like that, it's going to get passed to the task sequence. One of this structure that I have I'm using here in this demo, we're putting it into production probably the beginning of February when our current build is going to go to production. Prior to that, I had the success and failure groups that did everything. I had an awful lot of redundant work in it. Both the failure and success groups, did the same drive mappings, the same logging, the same everything was duplicated. And the difference would be that last action succeeded variable. If it was, again, false would fall into failure, true would fall into the successes. The stumbling block would be, so you'd have a successful build, it would drop into the success group, and you did get one of those times where something in that success group would fail. That sets that variable to false, and then stumbles into the failure section, and then undoes everything that you had in the success group. So I came up with it, this way, structuring it differently. The failure and success groups are keyed off of two separate independent variables. The last action succeeded for the failure. At the end, probably should pop back. You see at the very end of that, come on, right there. So TS variable all steps succeeded. If the task sequence, everything in the build task sequence succeeds, that'll get set to true. That variable is what's used to key off of in that success group. So that's why in the failure, I want to be sure to set that to false, so I then don't accidentally stumble into the success and reverse everything. So let's say you had in the failure group, you zip up the log files, copy them up to the server, page the on-call, trigger the machine not to reboot, something like that. And then if you accidentally stumbled into the success group, maybe the success group is clean up any old logs out there, so it deletes the logs and sets the machine to shut down. You've already paged the on-call, they come on, they got no logs, nothing to go with. So that's a safety net to keep it from falling in there. Talked about that. All right, the finally section. I love task sequence variables. I'm just going to put it out there. Using them all the time. All right, so in this case, very first thing I do is I set the variable for the server that I'm going to connect to. In my lab, it's FS01, file server 1. Why? All right, because before I used to hard code in server names, and you get bit once by having to change it and finding it all through your task sequences and looking them up in scripts. No more. So I got the one variable set there. If I got to change my server name, I just change that. That then falls into setting up the variable that will be used to make the network connection. Same thing. Just got to change the variable once. Don't got to worry about it anywhere else. Use my network access account to connect to it. Don't have to use the NNA account. You can use any kind of account you want. And then I run the script. So the script here, and I'll pull it up here in a moment, it's pretty straightforward. It's a PowerShell script, and it'll get past the one variable, the OSD results, whether it's success or fail. And then it'll go through and it'll collect the variables that I've put in the script. Things like the task sequence ID, the task sequence name. It'll take the start time and the time the script runs and calculate out the elapsed time. I threw in some other ones there just for demonstration purposes, but it'll gather all that up and it'll write it all up to the CSV file. Then when it's done, it disconnects. This is a sample of the CSV file. You can see pretty simple, straightforward. I got the computer name, start, finish time, elapsed time, the model information. This is like a screenshot of that sample file that I have. Like I said, it's about 500 records in there. It's all pre-populated. It's got some various failures and successes, different makes and models, things like that. Again, it was just put together so to use as something to play with Power BI. Okay, almost there. So you got the data collected, and you want to figure out how to actually use it in Power BI. Come on. There we go. All right, so this is just a workstation I got set up in my VM lab, and that's the Power BI report that's like I said, up on the GitHub. That's based upon that sample file. Some of the cool things about Power BI is all the graphs are all interactive, and you saw some of that with Justin's presentation. If you want to just look at your successes, you hit the select or the success part of the pie graph, and everything else reflects, what that selection is. So that was something kind of cool that drew me to Power BI. So I'll start with a blank one here. Quick rundown. It's pretty familiar. You got your ribbon like we have any kind of other Office app. The visualizations. These are all the various charts you have. Based upon what chart selection you have, you different fields to fill in for us. Depending on how the chart's going to manipulate that data. Over here in fields, after I bring in the data, all of my fields will show up in here that I have available to me. Well, it's simple. You get data. Now, another cool thing about Power BI is you just have a whole cornucopia of sources that you can pull your data from. But like I said, I like to keep it simple. So you could select just a CSV file. The problem is with that, you get a new CSV file, you then have to go back in here and repoint it. Instead, you just select a folder. So what Power BI will do is, let me just point it at my demo here. It's going to go out into that folder, and it's going to find, in that case, I got 2 CSVs out there. Safety nets again. It'll pop up and it'll show you what files it defined in there, because it's going to consolidate it all into one data table. So if you have an errant file in there, that will throw all your columns off, this is your chance to catch it. But this is all right, so I'm just going to tell it to combine and load them all. It's going to go out and start pulling that information in. It's next going to present what it found in those CSV files. Again, it's a safety net. If it got to this point and you found out you got your column headings not matched up with your column data, like, instead of starting date times, you get your task sequence ID in here, it's your chance to fix it before loading it in. But again, all looks good. Now what it's going to do is actually going to consolidate those CSV files, load it into its internal data table, and I'll start seeing my fields just populate over here. Boom. All right. At this point, it's all clicking and dragging. So let's say for your success rates, pie charts are great for that. You just click on a pie chart and make it a little bit bigger over here. So now, like I said, when I have nothing selected, you don't have many fields that you have to worry about here, but select your pie chart and you get a number of fields you got to worry about. Well, like I said, success or failure is recorded as part of that OSD results. Just a matter of dragging it over here to values. Right off the bat, all right, so I got 100% of something. What it did was it's going on, it just totaled up everything that I found in there, because I didn't tell it how to break it down. If I take that same field, drop it over here in Legends, it'll split it up by successes and failures. Not the best looking graph by any means, but it's a start. The little paint roller icon here, this opens up your panel that has all of your customization settings for Power BI, or all of your customizations for that graph. Now, we know usually green for success is okay, but usually failure is going to be red. Change your colors. Data labels, it's going to be, you can't, even on the big screen, you can't even see the success and failure up there. So, bring those up a little bit so now you can actually read them. Category. The label of category, that's what it found in there, success, failure, because that's all that's in that column. The data value, it's going to actually total up, show you how many successes and failures, the percentage of them, or you know what, just give me all three. And you can add, titles, you can change the background color, you can throw a border around it, anything you want to do with it. Sky's the limit, essentially. Failure reasons. That's another good one. Okay, let's start with a fan chart here. So if the task sequence were to fail, or have a failure, the failed action gets recorded in the CSV file. That's thrown into the column called failure reason. Oh, and it helps if I actually keep it selected. Failure reason. All right, similar to the pie chart, you just total up everything. I need to tell it how to break it down. Same thing, failure reason, drop it into the group category. All right, so we got, it's a little bit better on the big screen. You'll see successes outweigh everything else. Well, we were just interested in the failure reasons, right? Let me just filter that out. Now I could pick and choose. Come on. If I wanted to, I could just pick and choose the individual and keep the success deselected. But, if then you would have to keep having to go in here and making sure you select all your failure reasons. You just change it to advanced, tell it, show me everything that is not. And as long as I can spell success properly here as I type, which I did not, of course. Yeah, okay, so it then filters out successes in that chart. And you have filters available on each individual chart. Let me collapse this here. So visual level filters would be filters that apply to that particular visual. You can have page filters. You can have multiple pages in here. You know, a page level filter would apply the filter to everything that appeared on that page. So let's say you had a page devoted to just purely recording stats on failures. You could set that same filter taking success out, apply it to the page, and every chart or graph, just, table, everything you put in there would only display information related to those machines that failed. Okay, fan chart's not too bad. Well, maybe a bar chart would look a little better. All I got to do is just change your visual. Power BI will keep track, and it's not going to reset everything. If you change colors, it'll keep the color codes, all that kind of stuff. You want a visual, a vertical pie chart, or vertical pie chart. Good job. The donut charts. I mean, anything. You could just keep popping along, and it'll retain that same information there for it. The elapsed time. Try to kill it real quick here. A card is just like a static display of your data. Another real helpful description. It's going to display, I'll pull in the elapsed time, which is calculated. One field, and it pops in there, 44,000. That doesn't sound like a pretty good build time. So what it did here is, since it's a number column, Power BI defaults to totaling them all. So if I click this little down arrow next to the elapsed time, you see it defaults to sum. So it took all the elapsed times and just totaled them all up. And we're more interested in what's the average build time. Average build time is cool. Let's say you also want to know what the maximum build time is. Well, you can just cut and paste these things. And I'll just change it from average on this one to maximum. So it's, you can once you start, it almost gets to be playtime, for lack of any other way of putting it. But like I said, when you got it put together, and you got something that you like I took a look at these charts and I published them to our SharePoint server. So anytime there's any other question of how long does a build take, how many builds are done in a day, what's the main failure reasons, we can just point them all. Take a look at the SharePoint; it's all right there. All the hard facts are there and ready to go. So that's. Anybody have any questions? Didn't mean to rush it through, but.
You built the machine in 13 minutes. You built the machine in 13 minutes, or was that?
That's their VMs. So there's. I also don't have a lot of software that's being installed and nothing like that. So yeah,
All you do is apply a whim.
Yeah, apply a whim, boom, done. Any questions? Yes.
I was curious about this one too. After it was take roughly 2 hours, I was wondering if that's normal for.
How would you do it?
Can be. Yeah.
Hardware.
But it's this 10 number of applications. But yeah, it takes about 2 hours to do that.
That's not unheard of. But like I said, it kind of depends on what's all happening. Throw in Office and almost a dozen apps on top of it. That'll chew up time.
That alone takes 2 hours to work the application.
Yeah, so to get 2 hours is not unreasonable. I mean, you're doing a lot.
Yeah.
How are you doing your updates?
Yeah.
Talking specifically about the Power BI template.
Mm-hmm.
You build the template once, obviously, and then you've got the CSV data that's going to be changing as frequently as you send updates to it.
Right.
What do you do? Have you automated the process of just replacing the last month's CSV with this month's?
Depending on, Microsoft offers different levels of Power BI. You can get the full Power BI reporting server where you can schedule it, it'll automatically update data live. The little demo machine I have in here is just running Power BI desktop. There's just a refresh button, you hit it, and it goes back out, pulls all that data on in there. Jordan.
I was saying, I can talk a little bit
gateways are free, as well as they do the refresh on personalized gateway. And then there's a whole other layer past that, which is about $20,000, where you actually get a dedicated cloud instance of Power BI aggregate and store your data. That's when it gets stupid. And then there's Power BI Pro.
Right. Other questions?
Should we try using that with child task sequences? Does it work?
Yes. Yes. In
Task sequences?
child nested task sequences? Yes. In our environment, we've carved up our build sequence into all sorts of crazy nested sequences. And yes, like the variables I set for, whether it's prod, pilot, QA, all that stuff's like in the parent, and all the logging stuff's in a child. And that information passes straight through, no problem. And in fact, that child task sequence that handles the logging, I use that same child task sequence not only in my build, but also in my in-place upgrade task sequence and my compat scan task sequence. And it's just a plug-and-play module. And all I got to do is just change the variables at the top of the sequence to feed into it.
Mike, can you put back your contact page for the data?
Sure. Other questions?
What else are you using on Power BI?
Primarily this. Well, this is essentially OS deployment information. I have similar charts that I use for reporting stats on our Windows as a Service stuff, the in-place upgrade and the compatibility scan. Like I said, the logging module child sequence just plugs right into the end of those two. So I have similar Power BI reports that show, builds, in-place upgrades, compat scans. Yes. Well, it's just a plain flat CSV file that's out there. I tend to avoid SQL because spelling SQL is about the best I can do as far as SQL is concerned. So, like I said, that's why I went with the simple CSVs. Other questions? Cool. Thank you very much.
Awesome. Thanks, Mike.